Mudrock, hit the lights. Good morning, pre-calculus. Today is the second part of section 9-1, sequence and series. So today we're going to look at factorial notation, which is covered on your book from pages 644 to 645. All right, the first thing we got to do is define what does n factorial mean. So again, this right here, this little symbol means factorial. Does not mean exclamation, but it means n factorial. This here is the setup of it, how you would go about and do it. But I thought, let's just do it by example. That's probably the easiest way of doing it. We could do it two different ways. The first way is without using a calculator. So 4 factorial means 4 times n minus 1. We already know n is 4, so we go 4 minus 1 times 4 minus 2 times 4 minus 3. Do your order of operations, and you'll get 4 times 3 times 2 times 1. Order of operations, and we will find that 4 factorial is 24. Now, you can also use your calculator. Great tool to have is type in the number 4. Go to, let me just set up my calculator here. You'll see it too. Turn it on. Hit 4. Click on the math button. Scroll all the way over to PROB, which stands for probability. You're going to use number 4, which has to deal with factorial. And then hit enter. And there you have 4 factorial becomes 24. So I showed you how you can do factorial without a calculator and with factorial. So let's do some other examples, okay? Another example is finding or evaluating this factorial expression, which is 9 factorial being divided by 3 factorial times 7 factorial. Now, this way I did this one without using the calculator. We already know 9 factorial is just 9 times 8 times 7 all the way down times 1. 3 factorial is 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 all the way down to the product of 1. You can see that. Now again, since we're dealing with the division of fractions, we can cross-cancel like factors. And what we'll be left with is 9 times 8 all over 3 factorial. And if you do your math, you get 72 divided by 6, which gives you 12. Now you can do the same exact problem, but you can use your calculator. It's really simple. All right, so we'll go 9 math prob 4 factorial divided by, make sure you do parentheses around your denominator, 3 math, math probability factorial times 7 math probability factorial, close it up with the parentheses, hit enter, and you also get 12. All right, that's how you would evaluate factorial expressions. All right, page 2. Roman numeral 3 deals with summation notation. Now the summation notation really is very useful when we get into a series. Now again, I flew by real fast on section 9-1, the sequences and series, but sums are really applicable to a sequence. So here, yesterday we talked about sequences of an arithmetic sequence, and we also talked about a geometric sequence. Now, if we have a sequence of whether it's a arithmetic or geometric, we can find its series. Now, a series is nothing more than taking how many terms you want to find the adding of. So in other words, like a good example here, okay? Like this problem we did yesterday, 7, 9, 11, 13. If we were to add up these 4 terms, this would give me the series of these 4 terms. if I take this geometric sequence, and if we were to add up these four terms, this would give us the series of these four terms. And now, in this section 9-2, you can do that type of stuff by using summation. And summation is nothing more than this little funny little symbol right here. It's the sigma. And it says sigma equals where we're going to start at. So we're going to start with the first term. Okay, whatever our value or whatever our number in our sequence is, the first term of the sequence, all the way up to the nth term. In this case, how many terms we want to do. So if we go back to this problem right here, we could figure out what the series is of these first four terms. So the n here, we're ending up, this will be represented as your fourth term. So summation of starting from 1 going to whatever term we're dealing with in our sequence. And this right here is our formula, okay? Whether it's a geometric sequence or an arithmetic sequence. And it's nothing more saying that we're going to take each term of our sequence and add them up. So I should have done this example using the arithmetic sequence in section 9.1, but I did not. So here's an example, okay? Here I have the summation starting off with the first term going all the way up to the fourth term of this equation right here. 3 times I plus 1. So again, I did this by math, okay, without using the calculator. So you go 3 times 1 plus 1, 3 times 2 plus 1, plus 3 times 3 plus 1, plus 3 times 4 plus 1. And again, this 1, 2, 3, and 4 is starting off with the first term all the way up to the fourth term. And then if you do your math, 4, 7, 10, 13, that gives you 34. Now if you go back, okay, great example here, okay, see how this is 4, 7, 10, 13? That's an arithmetic series. They're all increasing by an increment of 3 units, okay? And we can use this part right here. They figured this out for you. Okay? We did this in the last section. Now you can also use this on your calculator, okay? So let's, for example, I want to do the same problem. We already know it's 34. So what you want to do, very simple. Let's keep calculator here. Let's clear our screen. So the first thing we do is you go to math. Now under math, look for the button that says summation, this symbol. Hit enter. Again, we want to start off with our, again, you can use I, but I'm going to use X because it's already in your calculator. X, starting off with the first term, moving your cursor up to the fourth term, and over here, this is your equation. And if you hit enter, you also get 34. So again, if you want to use your graphing calculator, just remember, hit the math button, find this symbol right here, plug in X for the first of the low X down here, whoops, X, what term you're starting off with. We're starting off with the first term, and what term are we ending up with? Well, in this case, it's 4. Plug in your appropriate equation. All right. Now, the next thing, Roman numeral, okay, also within pages 646 to 647, there are your properties of sums. You need to take a look at page 647. Again, you can follow that without any problem. Now, basically what I just showed you a moment ago is series, page 647. Again, whether you're dealing with an arithmetic sequence or a geometric sequence, you can figure out what this is right here. The nth term of your sequence or a sequence, and wherever you want to start off with. You want to start from the first term and go all the way up to the 100th term, you can do that, okay? So that's Roman numeral 4. All right, I think that takes care of section 9-1. Again, try your hand at it, read your book. You'll have absolutely no problem. Thanks, guys. Catch you later. 9-2 is next. Bye.